Arranging digits. Now, why deal with arranging digits? Consider this example. Example 1. How many 3 and 4-digit numbers can be formed using the digits 1, 6, 7, 8, 9 if repetition are not allowed? B. How many 3 and 4-digit numbers will be greater than 7,000? And C. How many 3 and 4-digit numbers will be odd numbers? So that's a given question. Now let's get straight to the solution. Now from the question, we need to bring out the digits. The digits, they are 1, 6, 7, 8, and 9. The A part of the question is, in how many ways can we form a 4-digit number and a 3-digit number from this set of numbers without repeating any of them? Well, it's quite easy. Just follow this process. Now, let's open a box for the 3-digit numbers. Let's work with the 3-digit numbers. And this box contains the 3-digit numbers. Assuming we're going to insert a number in this 3 space over here, which will form the 3-digit number. So how many of these numbers can we use as the 100? There's 100 times and units. So any of this number here can appear in the 100. So we have 5 numbers, 1, 2, 3, 4, 5. We can put either one here. 6 can appear here, 7 can appear here, 8 can appear here, and 9 can appear here. So 5 of the numbers can appear in the 100th part of it. So what about the tens? Now you should note that at this point, a number has already appeared here. Out of this 5, there's already a number here. So since we don't want to repeat, it means that the numbers that can appear here will be 4. Assuming we're going to assume that 7 is here already, that the number in 100 is 7, so we'll be left with 4 numbers left, which are 1, 6, 8, 9. So the numbers that can appear in tens is 4, because repetition is not allowed. How many numbers will appear in units? We should take note that another number has appeared here. Now, let's assume that number is 6. So we're left with 3 numbers left, 1, 8, 6. If there's 7 here, 6 here, 3 numbers will be left, and that 3 numbers will appear here. If repetition is now allowed, the first slot can contain any of the 5 numbers. Then the other slot will contain 4, because the first one, a number is there already. While the third one will contain 3, because the previous 2 slots contain one element each. Hence, the number of ways we can arrange 3 digits from this set of numbers is equals to 5 times 4 times 3, which will give us 60. So that's 60 ways of arranging 3-digit numbers from the set of numbers. So now let's proceed to 4-digit numbers. In 4 digits, we're going to create 4 slots. Now this will be the thousands, 100 times in units. Now, how many of these numbers can appear in the 4 slots? Of course, any of the 5 can appear here. Now, assuming the first slot took 1 number, so 4 numbers can appear here. Now, this one will also take 1 number, then 3 will appear here, so we'll take 1 and 2 numbers will appear here. It's as simple as this. The number of ways of arranging 4 digits is 5 times 4 times 3 times 2, and when we multiply it, the answer will be 120 ways. So since there are 60 ways of arranging 3-digit number and 120 ways of arranging 4-digit numbers, the number of ways of arranging 3 digits plus 4 digits, it will be equals to 60 for the 3 digits plus 120 for the 4 digits, and that will give us 180 ways. So that is the answer. So let's solve for the B part of it. The B part of the question is, how many 3 or 4-digit numbers will be greater than 7,000? So first of all, let's work with 3 digits. How many 3 digits will be greater than 7,000? Okay, so we'll create 3 slots. Now let's remember the digits we're working with. The digits we're working with, they are 1, 6, 7, 8, and 9. So if we're going to arrange these numbers in these 3 slots, how many of these numbers will be greater than 7,000? Of course, no one will, because this is a 3-digit number, and this is 4. Now the highest number we can get from here, okay, let me start from 9, being the greatest. 9, 8, 7. This is the highest number we can derive from the set of numbers working with a 3-digit number, 997. 997 is not even up to 1,000. And the question is, how many 3-digit number will be greater than 7,000? It is impossible for any 3-digit number to be greater than 7,000. Hence, no 3-digit numbers is greater than 7,000. So now let's proceed to work with 4 digits. How many 4-digit numbers will be greater than 7,000? So let's create the slots for 4-digit numbers. Now, for a 4-digit number to be greater than 7,000, it implies that the thousandth here, this is thousands, hundred, terms, and units, thousandth here must be 7 and above. If the slot containing number 6,000 something, of course, that number is less than 7,000. So this slot here must be from 7 and above. So how many digits here is 7 and above? 7, 8, 9. So there are 3 digits. 7 can appear here, 8 can appear here, 9 can appear here, but 1 and 6 cannot appear here. So this first slot can contain only 3 objects. So here will be 3, not 5, because 1 and 6 can't appear here. And of course, this slot can contain all the objects. But remember that one of it is already here. Out of this 3, one of it is already here. It can be assumed that probably it is here already. So we will be left with 4 objects, 4 numbers. Then this slot can contain any of them, but there are 2 here already. So it can contain 3, and here will contain 2. So when we multiply number of 4-digit number greater than 7,000, the answer is 3 times 4 times 3 times 2. By the time we multiply, 3 times 4 is 12, 3 times 2 is 6, so 12 times 2 gives us 72. So there are 72 4-digit numbers greater than 7,000 and no 3-digit number greater than 7,000. So the answer is 72. Now let's proceed to the C part of the question. The C part of the question is, how many 3 and 4-digit numbers will be odd numbers? How many 3 and 4-digit number will be odd numbers? Let's write out the digits we are working with. The digits they are 1, 6, 7, 8, and 9. How many of 3-digit number and 4-digit numbers will be odd numbers? So let's work with the 3 digits. We'll create 3 slots for it. Now, how many of these numbers can be an odd number? Remember that odd numbers are numbers that, when divided by 2, it has a remainder. The easiest way for us to detect odd numbers is that odd numbers always end with these digits: 1, 3, 5, 7, 9. So if any numbers end with these 5 digits, that number is an odd number. So right now we're interested in the units. We're interested in this slot because this slot cannot contain all the numbers. Numbers that will appear here must be one of these 5 digits. So which of this number here contain these 5 digits? Like 1, 7, and 9. So it is only 1, 7, and 9 that can appear here. This slot cannot contain those even numbers, but contain only the odd numbers for just this unit part of it. So 1, 7, and 9 will appear here, so just 3 numbers can appear here. So this part is settled. So let's move to the first slot. So this first slot can contain any of this, but this third slot has had one number already. So since he had one number already, this first slot will contain 4. This second slot can contain any of these numbers, but there's one here, there's also one here, so this one can contain 3. So the number of arranged 3-digit number that will form an odd numbers from this number is 4 times 3 times 3, and this is equals to 36. Let's proceed to 4-digit number. We'll create 4 slots. So the first principle applies. Since we are dealing with odd numbers, it means that this last slot must be an odd number. The previous slots can contain even or odd, doesn't matter, but the last one must be an odd number. So we have 3 odd numbers in the question. So here's 3. So any of the 5 numbers can appear here, but there's 1 here already. So you can take 4. Any of the 5 numbers can appear here, but there's 1 here, there's 1 here, so we are left with 3, and we're left with 2. So 1 multiply is 4 times 3 times 2 times 3. This is 12 times 6, 12 and 6, which should give us 72. So by the time we add these two numbers up, 36 plus 72, the answer is 108. So there are 108 odd numbers that can be formed from 3-digit number and 4-digit number in this set of numbers. So let's move to example 2. How many 3-digit numbers can be formed using the digits 4, 5, 6 if no repetition are allowed, and if any digits can be used more than once? The digits we're working with is 4, 5, and 6. Now in the first condition, no repetition is allowed. How many 3-digit number can be formed? So let's create 3 slots for the 3-digit number, which is 100 times a unit. Now, this first slot can contain any of the 3, so that's 3 here. Remember, repetition is not allowed, so since 1 digit is already here, this one can contain 2, and this will contain 1. So it becomes 3 times 2 times 1, which is equal to 6. So it is only 6 digits can be formed from 4, 5, 6 when repetition is not allowed. But now consider when repetition is allowed. We have 3 slots. Now, in this case, these 3 numbers can appear here. So since repetition is allowed, assuming we already have 6 here, it means that the number 6 can also appear here. The 3 numbers can also appear here. And the 3 numbers can also appear here. So there's a difference between when repetition is allowed and when repetition is not allowed. When it is allowed, the number of digits is just constant. It will appear in each of the slots. But when repetition is not allowed, the number of digits will start decreasing because the number that is here can't come forward to the next slot because repetition is not allowed. And when we multiply this, we have 3 times 3 times 3, which is equals to 27. That's the answer. Example 3. In how many ways can the letter of the word pencil be arranged? I. How many of these ways begin with the alphabet E? I. How many end with the alphabet P? And how many begin with E and end with P? The first part of the question is, in how many ways can the word pencil be arranged? There are so many ways we can arrange the alphabet P-E-N-C-I-L. For example, it can be rearranged to E-N-C-I-L-P. It can also be arranged to N-C-I-L-P-E. There are so many ways that we can rearrange this word. So the easiest way to solve this problem is to draw 6 boxes because we have 6 alphabets, which are 1, 2, 3, 4, 5, 6. So we're going to draw 6 boxes. So we have the 6 boxes. Now the next step, since we have 6 alphabets, any of these 6 alphabets can appear in the first box. So we assume that one of the alphabets is here already. So the second slot can take any of the other 5. So 1 is here already, the other slot can carry any of the other 4. So since there's 1 here already, the other slot can carry any of the other 3. Next one carry any of the other two, and this one will have to take the last one. So the number of ways that we can arrange the word pencil, which is 6 alphabets, is 6 times 5 times 4 times 3 times 2 times 1. And this will give us 720. So that's 720 ways in which we can arrange the word pencil. We need to take note that this format will work only when none of these alphabets repeats itself. Assuming there's an alphabet that repeats itself, then the method we're going to use will differ. But still, there's a formula when more than one alphabet repeats itself, and that is under permutation involving identical objects. You can click on the link above to access that video. So let's proceed to I. How many of these ways begin with E? Out of those 720 ways of arranging the word pencil, how many of them will begin with E? So with the help of 6 slots, we'll be able to determine it. Remember, the word pencil contains 6 alphabets, so let's create 6 slots for it. Assuming we're going to rearrange it. Pen. So the question is, how many of them begin with the letter E? So if the words are to begin with E, it means that this first slot must contain only one object, which is E. P cannot appear here, N cannot appear here, neither C, I, or L. It must be E alone because we're looking for words that begin with A. So this second slot can contain any of them. But remember, the repetition is not allowed, so E cannot appear here, since E is here already. So we'll be left with 5. It can contain any of the other 5. This one can contain any of the other 4, the other 3, the other 2, the other 1. So it becomes 1 times 5 times 4 times 3 times 2 times 1. So this will give us 5 times 4 is 20, 3 times 2 is 6, and it's equals to 120 ways. So let's move to II. So in II, the question is, how many end with P? So let's create the 6 slots. 1, 2, 3, 4, 5, 6. So how many of those alphabets will end with P? So it means that the last slots must contain only P, which is 1. E, N, C, I, L can't appear here, so here can contain just 1. So out of the 6, which all can appear here, but 1 is here already, so here will be 5, 4, 3, 2, and 1. So 1 will multiply 5 times 4 times 3 times 2 times 1 times 1. 5 times 4 is 20. 3 times 2 is 6. 20 times 6 is 120 ways. I. How many begin with E and end with P? So let's create still 6 slots. We're looking for the number of alphabets that begin with E and end with P. So it means that this first one begins with E, just 1. This last one ends in P, just 1. It is only E that can stay here, it's only P that can stay here. So any of the 6 alphabets can appear here, but 2 of the alphabets are already in use. So we'll be left with 4 here, 3, 2, and 1. 1 will multiply 1 times 4 times 3 times 2 times 1 times 1. 4 times 3 gives us 12. 12 times 2 is 24. So the answer is 24 ways. And that is the answer. In my next video, I'm going to talk about combination. You can click the link above to access it. Meanwhile, if you have any question, you can ask me on WhatsApp. Subscribe to this channel, like and share this video. I will see you in my next video.